This is our test review for what should be labeled up here, Unit 6, the periodicity and bonding test. It is not Unit 7. The other thing we need to note is right here, the directions clearly say that you should be answering this on a separate sheet of paper. No credit is going to be given to reviews done on the page. So again, this is Unit 6, Periodicity, Vesper, and Bonding. You should be writing your answers on a separate sheet of paper, not on this page for credit. Let's start with some definitions from our periodicity notes. The tendency for atoms of an element to attract electrons is going to be known as electronegativity. Another term you might hear for the same thing is electron affinity. So either term can be used to talk about the tendency for atoms to want electrons. If we look at the trend, if we're going left to right, this is going to be a period trend. Remember, periods are the horizontal rows, and this will be increase. So we will have an increase as we go from left to right. If we look from top to bottom, we said that is a group or family trend. We said things in a vertical column were more closely related than things in a row. So this is the group and family, and we said that this would decrease top to bottom because those at the bottom have lots of electrons and they really don't want more. Which group of electrons does not have this trait? That would be our noble gases all the way over on the right-hand side, known as group 8A or group 0. The energy required to overcome the attraction and allow us to remove an electron is going to be known as ionization energy. If we look at our period trend left to right, it is increasing because those at the far right, remember, are trying to get electrons to complete their octet. Those at the far left are trying to give them away. As we go top to bottom, it's going to decrease because it gets easier to pull an electron from an element that has lots of electrons. All right, definition here, atomic radius is going to be the distance, or 1/2 the distance, between two nuclei. If we look at the period trend here, going from left to right, that is decreasing. We said as we go from left to right, we are going to be adding a negative electron as well as a positive proton to the nucleus, which will cause the electron energy level to be constricted or more tightly attracted to the nucleus. As we go down the group from top to bottom, it's going to increase because we are adding energy levels. When we look at the size of an ion, we call that ionic radius or ion size. You could use either term to describe the size of the charged particles. As we go left to right across the period, it is going to increase because we are adding. And then as we go top to bottom, it's also going to increase, again, because in this case, we are adding energy levels. Cations are always going to be smaller than the atoms from which they came because they're giving away electrons, while anions are always going to be larger. This concludes the section on the definitions of our periodic trends. All right, so now when we look at questions about our different trends, which element has the higher first ionization energy, sodium on the left or chlorine on the right? It's going to be chlorine. Which element has the higher atomic radius? Again, sodium's on the far left, chlorine's on the far right. That will be sodium, Na. If we're going to rank our group 2A elements, group means a vertical column. According to electronegativity, we said those at the top are going to be more electronegative than those at the bottom. So BE is going to be at the top. So if we're doing it in increasing order, we're going to start at the bottom with radium, and then go to barium, and then go strontium, calcium, magnesium, and end in beryllium. If we look at our period 2 elements that's going across the row, we said when we looked at ion size going across the row from left to right, they will increase. So that means we're going to do lithium, then beryllium, then boron, carbon, nitrogen, oxygen, fluorine. Okay, which element on the periodic table has highest electronegativity? In this case, fluorine. If you look at your electronegativity table, it's 3.98. Remember that our noble gases have an electronegativity of exactly 0. Largest atomic radius is going to be lower left. That will be francium. Highest ionization energy is going to be your upper right corner, depending on whether you're including the noble gases. If you're not including the noble gases, it would be fluorine. If you are including the noble gases, it would be helium. Lowest ionization energy, again, is going to be lower left, so we're back with francium. And smallest ionic radius is going to be hydrogen. Okay, this concludes all of our discussion about our periodicity traits.